Okay, I want to look at systems of linear equations in two variables. Linear equations in two variables always form a line, so really we're looking at a system of two lines. And first what I want to discuss is what a system of linear equations in two variables typically looks like. So a pretty standard linear equation in two variables might be the equation y equals x plus 3, and another one might be something like y minus 2 equals x plus 1. So the system of linear equations usually is joined by this symbol here on the left, and so that means these two equations are considered together as one unit. And if you are told to solve a system of equations in general, you're looking for any ordered pair in this case that makes both equations true. So for example, the ordered pair, if x is 0 and y is 3, that means in the first equation 3 equals 0 plus 3. Well, that's a solution because 3 equals 0 plus 3, so that's okay. And in the second equation, if you plug in a 3 for y, the left side gives you 3 minus 2, which is 1, and on the right side, if you plug in 0 for x, you get 1. So this ordered pair is a solution to this system. So a solution to a system of equations or a system of two lines is any ordered pair that makes both equations true. So what does that mean about their graphs? Well, let's discuss solutions in general now. So if you have two lines, you can think about it pretty easily here. Two lines typically will maybe look something like this, where eventually they touch, and so the ordered pair where they touch is the one solution to this system. So this system has two lines. They intersect at one point, one ordered pair, so that ordered pair is the solution. So the solution is whatever that ordered pair is. Okay? And again, that depends on your coordinates for that ordered pair. So how can you describe two lines that touch? Well, if two lines have different slopes, they will touch. So any two lines that have different slopes, when you consider those two lines as a system, that system will have one solution because they will touch at exactly one ordered pair. Okay, so what's a different possibility then? Well, another possibility is if you have two lines that look something like this. These are parallel lines that never touch, so there's no point of intersection. That means the solution to this system, if you graphed them, the solution would be no solution. There is no ordered pair where both equations are true because there's no ordered pair that's on both of those lines. Okay? And so you can tell when two lines are parallel because the slopes are equal. Okay? And there's one very last possibility. So two lines touch or they don't touch, or they are maybe the exact same line. So the two lines are the same, which in this case they intersect at every single point on the line, right? Because every point would be common to both lines. So in this case there's an infinite number of ordered pairs, infinite number of solutions which are ordered pairs. And so how can you recognize when two lines are the same? Well, of course their slopes will be equal because they're the same line. So the difference between two lines that are the same and two lines that are parallel is that in both cases the slopes are equal, but over here the y-intercepts are different. And over here the y-intercepts, because they're the same line, are the same, of course. Okay? So you can look at the slope and y-intercept and tell how many solutions there are. Over here, the solution would be there would be an infinite number of solutions, so how do you write all those ordered pairs? You use set builder notation, and it's the set of all ordered pairs x comma y such that, and then you have to write the equation for this line. So whatever this equation is goes here. And that's a little bit about systems.